Good morning, everybody. Welcome to yet another amazing smart contract tutorial, where in this tutorial we are going to be building the ultimate ERC-1155 smart contracts. We are going to include the mint functionality. We are going to include the payment requirement, which is how making sure that people actually pay for your NFT, right? We are going to include a supply limit, right? Meaning there's a limit of 10,000 NFTs, let's just say. And we want to make sure that people do not go above that. We're going to create the Allowlist functionality, which is, to give the VIP, the people who are the biggest supporters of the project, give them the ability to mint for a lower price or give them some special options, right? So we're going to create that functionality in this smart contract. We're going to create the withdrawal function to withdraw the money from the contract. And then finally, this is a really cool part where we will create a payment splitter in the actual contract as well. Now, so what does that mean? Basically, let's just say you have, developer, creator, you have the founders, right? You'll be able to split post-mint payment, 50%, 10% there, 10% there, basically through the contract itself. So yeah, that's pretty much it. Welcome, everybody. Hope you guys have a great day, because I am excited for this. Let's get this party started. Okay. The first thing we're gonna do is going to be the following. As you can see right here, right, we've got OpenSea open, OpenSea open. So let's start out with creating our first ERC-1155 smart contract. But before I do that, Nas, what is an ERC-1155 smart contract? How does it compare to ERC-721? I have no idea. So here's the difference, okay? If you want to think about like, ERC-721, let's just say right here, ERC-721, ERC-721 smart contract, right? This is the original smart contract that was created. CryptoPunks used it first, then we got the Bored Ape and stuff like that. So they were the original pioneers. This contract was the original pioneers. And with this smart contract is so cool because, you can own unique NFTs, right? And so forth, right? Now, but what it also means is that only one person, one owner per NFT. That's right. Where ERC-1155 changes is that at this point you can actually have multiple owners per NFT. Interesting, right? So now I was like, what the heck? What does that mean? Well, let's take a look at this. One really cool one that is an example is like this one here. We have the Adidas Originals into the metaverse right here. As you can see, there's only 2 NFTs, right? We've got the first edition, the second edition. And if you go to these NFTs, you will see that how many owners are there? Well, you will see that there's actually 4.4 thousand, right? So 4.4K owners right here. Right? So that's what you'll be able to do on your side as well, is that this is very much used for utility purposes. Let's just say maybe you want to create an NFT project to be able to give access to a certain portal, right? To be able to give access to, I don't know, maybe you have someone's subscription. We've done this for other projects as well, and it's been pretty successful. And so you can do this also for your NFT project, okay? Now, one really cool thing, one of the projects that we did just launch recently was called the Zuckerus. I want you definitely, guys, check this one out. We were a big part, we've designed this whole thing. This is a really, a lot went into this, right? Look at this, how beautiful this page looks like. The animations, the universe, the art, it looks so amazing. And we have designed it, and want to make sure you guys check this one out, because really, this is going to be a cool one. I really believe so. Okay, beautiful, awesome. But let's get into the ERC-1155 functionality behind this, right? Let's just start out with creating the ERC-1155 smart contract right away, okay? So what I want you guys to do right now is go to OpenZeppelin here, and go to OpenZeppelin. I call it the wizard, right? The Wizard of Oz. No, but the wizard is what's going to allow us to kind of set up the base smart contract, right? So here it is. We're on the OpenZeppelin wizard. We don't need the ERC-721, we don't need the ERC-20, but we do need the ERC-1155 right here, okay? Awesome. And let's go ahead and click on this one right here. right? And let's go and name our smart contract, right? Mine is gonna be called Web3 Builders, Web3 Builders. And the IPFS, guys, IPFS is a link. I actually have the link in the description. So if you guys want to check out the link, I actually have it right here for you. Let me see. Let me get that for you right here. The IPFS, this is where our images are stored. So here, I will go and copy this. Boom, boom, boom. As you can see right here. Boom, right here, right? So this is where our images are stored. And I have a few images stored in this IPFS link. We can cover IPFS in another video, okay? Beautiful. Now, moving forward here. We want to make this mintable. Burnable, not so much. Supply tracking, yes. We want to check the supply of this. And then, yeah, we can make it possible as well, right? And I think that's pretty much it. Now, at this point, let's go ahead and copy this. What's up, Faizan? What's up, everybody? Good to see you guys. As always, so many owners of the single... Yes, so many owners of the single token. That is very much correct. You are very much right here. I'll put you guys here. So many owners of the single tokens. Yes, exactly. As you can see with you know, Adidas Originals, there's like 4,000 owners, right, of this specific NFT. You can see here, and whenever they list something, it lists under one category, under one NFT. And why this is important is because if I just have a utility, let's just say it's an event, I might not need to have to create 10,000 different NFTs just to be able to bring my project into Web3, right? So why not just create one NFT that multiple people can own and have it just be like that, you know? So that's the goal with the ERC-1155, all right? Okay, we're moving forward here. Let me go ahead and remove this comment here, okay? Let's go ahead and copy this specific Web3 Builders contract. You can either click this. Honestly, though, it never works for me. That part never works for me. For some reason, this copy to clipboard never works for me. So I like to do it this way. I like to copy this myself manually. Okay. And then open up Remix. Boom. Remix IDE. This is where we are going to be, you know, doing our smart contract. Okay. Now, then let's go and create a new workspace. Let's go and name this workspace ERC-1155 Smart Contract. There we go. Hit OK. Beautiful. Awesome. These are the three beginning smart contracts we have inside here. I can zoom in this for you guys a little bit here, as you guys can see. Right, so you guys can have some better context. We don't need most of this stuff, honestly. So what we need to do is create a new smart contract and call Web3 Builders. So let's go and create under contracts, hit new file, and call it ERC. I'm gonna call it Web3 Builders. ERC-1155.sol. Right, Solidity, correct, right? And of course, we got nothing now at this point. So let's go ahead and paste this in. Based in our whole contract that we had, and just save it. And then honestly, it should be done at this point. It should be done. Here's what it looks like, right? Here's what it looks like. Pretty simple, right? So this is the base contract. I would call it that way, right? The most basic contract out there. Okay. We've got the set URI function, which allow you to change the URI. We've got our URI right here. We are importing the ERC supply, which allows us to track the current supply of the NFT, which is how many NFTs have been minted so far, so it will allow us to track that part. Pausable means you can actually pause the minting if you wanted to, right? Ownable, you have to have this one, guys. Is really important. Ownable means it shows who's the owner of the contract. And sometimes if you don't have an ownable contract, you will have an issue later on down the road with OpenSea, for example, or with like Variable. Trust me, I have learned the hard way, guys. Trust me. So you want to make sure you include this smart contract inside here. Okay. Okay. Let's go ahead now and go into the mint function. As I'm doing this, I'm gonna hit some music that's gonna be playing in the background while I'm working on this. Okay. The first things first we need to create with the mint function is remove some of this stuff and clean it up. Okay. As you can see, we have the account we're passing in to mint the actual NFT. Right now. In terms of the account, we don't need it because there's one really cool thing we can do to specify who's minting the NFT and that's using something called message.sender. Message.sender. okay? Now, message.sender, for those of you who don't know, what that does is that basically gives you all the data about which MetaMask account is actually making the transaction, right? So let's just say if you're minting, it's going to be your wallet address. If, you know, at the same time, we'll be able to see things like how much money are you passing into the contract? How much money are you giving to us, right? All of that stuff. So this happens in the message object, I call it, okay? Cancel this one. Awesome. Now, so remove that. Message.sender, beautiful. The ID is what ID NFT are we minting? Okay, then the amount, how many of those are we minting? And the bytes memory data, that's like external memory. We don't need to add as well. So that's going to be nothing. To fix this part, of course, let's go ahead and remove this data portion, right? And just give it an empty string, right? Because we're not really passing in any external data, right, for this, right? The account, we can remove this account section. Beautiful. And the other thing you want to look at this is the only owner part, which is what this is, right? Why is this bad? Because this means that only the owner of the contract can mint this NFT. And that's no bueno, right? That's like, oh, great, I just launched a smart contract, but I'm the only person who can mint the NFT. Hence, really, it's like, it's just for me, pretty much, right? So we don't want that. But what we do is we can just simply remove this. There we go. Awesome. And that's pretty much it. And now this, but you can mint the NFT. Oops, not here. Sorry, not the mint badge, but actually in the only owner part. There you go. See? So now anybody can mint this NFT, and that should be all fine, right? Now, after we've done the minting part, let's take a look at, you know, how do we make sure that, you know, someone is sending the payment. So the second thing we're going to work on is payments requirement, right? So this is, of course, you need to be able to require payment upon when somebody mints your NFT, right? So let's go ahead and do that. To require payment, you need to set the function payable. Very important here. So we have a payable. And what this does is this says, hey, this function right here is actually allowed to take payment. You take payment. Oh, thank you so much, Maluma. It says, your Insta Reels stories are amazing, dude. Thank you. Appreciate it, my friend. Appreciate it. So basically, as we, you know, as we pass in money to this, so you have to call this function payable. Otherwise, you cannot really pass money into this, okay? Now, we've got the payable, but doesn't mean we're actually requiring payment. So to require payment, what we need to do is say require. And those of you who don't know what require is, it's like, hey, make sure this condition is true. Otherwise, we stop everything. Otherwise, we stop everything underneath this. This is why it will never get to the main function. This condition is not true, right? So let's come require payment. To figure out how much money you're passing into us, again, we're using the message object. Inside the message object, we have something called a value. And value is how much basically money in way is given to us into the contract. Does that make sense, right? So let's go ahead and say message.value needs to be equal to what? Some kind of price. So let's go ahead and create a price above here. So what we can do here is inside here, okay, do uint 256. This specifies basically 256. I'm going to call this public price is equal to, let's actually make this a public price. Yeah. Public price, right, is equal to, what should we call this? Let's make this 0.01 Ether. And very important here, you need to understand this is Ether. You cannot say ETH, right? It doesn't exist. Ether, that's right. And at the end of the day, just so you know, this gets converted into something called Wei, which is kind of like a smaller version of Ether. Think of it as like you've got, you know, if you have inches, then you have, what's more than inches? Actually, I don't know. It's like inches, feet, and then like meters. I guess you can say. I guess is the way we would say this, right? So in our case, this would be like inches versus. This would be like feet versus Wei would be inches, basically, right? Just same amount, but different measurement of unit. Okay. So we got the public price. Beautiful. Awesome. Moving forward, let's go ahead and say measure value should equal to the public what? Price. Right? Basically. That's what it should equal to. Now, if that's not it, though, if it does not equal to the public price, then what we do is we say, hey, wrong, not enough money sent. That's it. Not enough money sent. That's right. Okay. Not enough money sent, right? So basically, that's going to be making sure again that we require payment in the contract. So let's go ahead and test this out and see how that works out. Okay. If I go ahead and the compile section, if I go to the deployment section, which is what this is, by the way, make sure in the compile section here, make sure you have auto compile on, which is very, very important. Okay. Make sure you have this on, and then go to the deployment section. And in this section, what I want you guys to do is deploy the smart contract. And now we're just going to deploy in the Remix London right here. So let's go ahead and hit deploy. Okay. Let's see what happens now at this point. Beautiful. Let's see. By the way, guys, while we're waiting, make sure to hit the like button, the subscribe button, whatever you gotta do. That really helps us out and me out. I want to keep growing this community. And so forth. So make sure, stay tuned for more videos like this. Awesome. We deployed our contract, as you can see right here. Here's our contract right here, right? So let's go ahead and scroll down. Make sure you open this up. We have all these functions you can see, and you might be wondering, you're like, Nas, where is these functions coming from? Is this like some mix-up? Is this a black box? No, it's not a black box, just so you know, okay? Not a black box at all. Actually, all these functions are defined directly in the ERC-1155 smart contract. So if you go to like ERC-1155 GitHub page, right, which shows you the actual code, all the functions like balance off, like for example, right, the balance off function. Let's look at back in Remix. Balance off right here. See right here. Balance off function, right? So all these functions are defined in the ERC-1155 smart contract, and that is what's actually allowing us to see these NFTs, because technically we are doing what? We are importing this smart contract into ours, and all we are doing is we're just adding on top of it. That's all we're doing. We're adding on top of this, right? Adding on top of this smart contract. Somebody said, hey, Naz, why aren't you uploading to YouTube? Guys, the reason why sometimes I don't upload to YouTube because we build NFT projects and we get really busy with this stuff. So, but I'm going to try my best to keep uploading more and more. Okay. Beautiful. Moving forward here. So to test out the mint functionality, let's try to hit mint. Of course, you specify what ID you're trying to mint. Or let's just say we're going to mint the first ID, which is usually what? 0. Mint ID of 0. That's the NFT ID. And the amount. How many? Let's just say 1 for now. If you hit transact, it says wrong, not enough money sent. Uh-oh, what do we do now? Good question, right? So to fix this not enough money sent, it's because we need to actually send money through Remix in our case, kind of like MetaMask, I want to call it. So we need to pass in 0.01 Ether into this value section, and then that's how we pass in money. But if I select Ether here, you will notice that I cannot do 0.01. because it only takes in whole numbers. You need to understand that. Whole numbers don't really work very well. What's up, Namla? Good to see you guys. I love how you guys are coming into this. I really appreciate every single person, every single one of you who are here right now. Okay? So as you can see here, when we add the value portion, we can only add whole numbers. So we need to convert Ether converter to what? To Wei. To Wei. That's right, right? Beautiful. Awesome. So let's convert 0.01 Ether. You see, this is this much Gwei and it's this much Wei. So it's like smaller units, right? Right now I'm just going to use Gwei. Why not? I will hit copy on this one, hit Gwei on this one. Go back to Remix. Type in, go select Gwei and paste in my Gwei. And now watch this, guys. Oh, one more person. Let's go. Amazing. Great to see you guys. And then now let's hit transact. And look at that. It's pending and it's minting our NFT and it's actually working, right? So we got the green check mark right here. And we can actually check the total supply right here. If I check the total supply, where is it? Total supply of the ID of 0, it should say 1. because only one person minted the NFT. Does that make sense, everybody? Beautiful. Okay, but here becomes the problem. What if I want to mint 3, right? Let's just say I want to mint 3 NFTs. Okay, what happens then? Well, I'm going to pass in my value of 0.01 Ether. Beautiful. And I hit transact. And look at that. It's actually transacting. It's actually transacting. It's actually minting 3 NFTs for the price of 1. And that, my friends, is a no-go. That is a no. No, I was trying to make it funny, but I really don't know. Don't have that like boo sign, basically, right? So what we want to do instead is we want to require price in the right way. And how do we do that? Well, think about this. If we want to buy 3 NFTs, what should the price be? 3 times the price. If you want to buy 4 NFTs, what should the price be? 4 times the price, right? So that's going to be our goal right here, is as we're buying here, we're passing in how many NFTs we want to buy. Let's just say 4 or 5, whatever it might be. We're going to say here, public price, it should be the value of how much money I'm passing in should equal to public price times amount, right? So 0.01 times 3, 0.01 times 4, 0.01 times 5, whatever it is. And now it will probably calculate the price for us. That's right. So if we go ahead and exit this part, hit deploy yet one more time, right? It's deployed. Again, make sure when you deploy, make sure you exit out the past smart contracts, hit deploy on this one. And if we try to hit mint at 0, right? Let's just say we want to buy 2 of these and we pass in this exact same amount of 0.01 ETH, right? Let's do that right here. Oop, come on. Boom, right here. Right, go away. It will tell us not enough money because we need to pass in 0.02 ETH, which in our case is how much? How much? It's 2, whatever this is, but 2, right? So now if I transact that, you will see, oh, I guess not enough. Let me see, 0.02 ETH. It's this much. So let's go ahead and remix here. Boom. Let's go ahead and hit transact. There we go. You see, now it went ahead and it went through, right? Because we passed in 0.02 ETH off that. Does that make sense, right? So there we go. So let me ask the question here. I want to answer the question. Is it possible to have multiple URI in the same smart contract? Example, collection where all metadata are the same, but all have the type right and others left, and they have specific methods for each of them. Yes, of course you can. Yes, you definitely can. To have different IPFS for metadata, let me go ahead and remove the comment here real quickly. Right, to have different IPFS, you have to use it's called ERC-1155 URI, which it stores the URI for every single NFT, right? And there's many ways of doing this, right? You kind of have to, it's like creating a piece of code whereby, I'm not really sure exactly what you mean by left and right, but you can specify when you give us the URI, or when you display the URI, which is going to happen here in a little bit here in the smart contract. You can say, hey, for these IDs have this URI, for these ID have this URI. So yes, it is very, very much possible. That's right. Okay, moving forward here, guys. So now, as you can see, we're requiring payment in the right way. The most important part, okay? Beautiful. Moving forward, okay, let's talk about the supply, right? So let's make sure we add supply tracking, right? Okay, and what is supply tracking for those who don't know? I want to see in the comments, guys. Supply tracking means that, well, if you look at Adidas here, for example, the amount of NFTs there are in total is how much? Let's look at this NFT here. It says the total, it's 5.8K total, right? That means there's only 5.8 thousand of these NFTs. Well, technically it's one NFT, but 5.8 thousand versions of the same one, I guess you can say it that way, right? So 5.8 thousand here. So how do we make that limit? It's the same as like when you go to, I don't know, like a Bored Ape NFT, for example, right? right? There's only what, 10,000 NFTs in general, right? The items is 10K right here. Right now, I can mint as many as I want. 1 million, 2 million, I don't care. So we need to add that supply. And to do that, again, we need to go ahead and create a requirement. So say require, right? Which is like some kind of a current supply. Some kind of current supply. Current supply should equal to, it's like a current supply is how much do we have so far right now, right? Just how many have been minted so far for this specific NFT. Should be less than or equal to what? The max supply. So our max supply, let's go ahead and define that. So we say uint 256, we say public max supply is gonna be equal to, let's just say, I don't know, maybe it's like, let's just say for now it's actually 1. I'm gonna like make a small number so we can probably test it. Let's just say max supply right now is 1, okay? And we want to make sure that it's less than the current supply should be less than the max supply. Right here, right? Now, the question becomes is where do we get this current supply function right here, right? And what we can do is very, very simple, guys. And there is a function in the smart contract, the total supply smart contract, and it looks a little bit like this here. If I can show you here, ERC-1155 supply here. Boom, 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 boom. Boom, 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 right here. Okay. You'll notice here that for the ERC-11 supply, no, not the one I'm looking for. Let me see here. Let me make sure. I want to show it to you guys where this is all coming from, because I want to make sure you understand that it's not coming from nowhere. Right here. Beautiful. Right here. We have the total supply function, which is total amount of tokens in the with a given ID. So it's how many tokens have been minted so far, right? That's what that gives us. Okay. So if I go back to my remix, we're going to use the total supply function, and we need to pass in for which ID. Because remember, we can have different supplies for different IDs. You know, for the ID of 0, it could be one ID. For ID of 1, it could be another ID. So in my case, it's going to be for whatever ID we pass into the mint function. And that total supply, which is, again, its current supply, it's just, I think the name is wrong, basically. Right? Should be less than the max supply, okay? Beautiful, moving forward here. So you had a question, now you need... That is right, you need to make so much art. That's right, I have so many owners, that's right. What if I have an NFT image? What if I have an NFT image minted and someone finds a way to save the picture and remint the picture as an NFT? What would that be? That can always happen, yes. You know, I can do the same thing with the Bored Ape NFT. I can do the same exact thing with Adidas. The way we prevent that is that when you launch your own NFT smart contract, you specify this is the official smart contract for this NFT, right? And so you'll see on OpenSea, there's actually, guys, a ton of clones of the same smart contracts, a ton of them, right? But the reason why they don't really work is because the original Bored Ape is tied to one smart contract. If you think about this OpenSea right here, this Bored Ape, right? How do we know it's the original smart contract? Well, you can go to this NFT, you can go to the details section, you click on the contract address, and you'll notice here, hopefully it opens up here in a little bit, you'll notice that it's part of just that contract address, right? Let me go and copy this section. Copy link, because sometimes it takes a while for some reason to open. Oh, there we go, right? So we know that it's part of this contract. Any other clone of the Bored Ape, right, cannot be part of this smart contract because they're not in control. Hopefully that answers your question, okay? Because that's a question that a lot of people have asked me, right? So let's say here again, going back to the supply section, right? Is the current supply less than max supply? But remember, if we're minting 10, let's just say, we need to add that to the current supplies. We need to say total supply plus amount should be less than max supply. Because if you think about it, let's just say the current supply is 0. Okay, just give you some ballpark here. Current supply right now is 0. Okay, what do we do now? And I want to mint 10. If I have this, then technically this is true, right? 0 is less than the max supply of 1, right? 0 is less than 1, right? And so I can mint 10 because I say I want to mint 10 here. Does that make sense? But in order to prevent me from doing that, I can say I have to add however much I'm trying to mint to the total supply right now, and then check that, okay? And now I can say, if this is wrong, I can say here, sorry, we have minted out. Minted out. There we go. Beautiful. You got that? Sorry, we have minted out. And that's pretty much it, guys. We minted out the project, means we crushed this, means we got this, means we can celebrate, whatever you want to do, okay? Whatever you want to do. Now let's go and test this part out. Again, let's go back to our deployment section, guys. Make sure you remove the past contract right here, and then hit X on this one. And let's go and deploy this again. Okay? And if we try to, let's just say we want to try to mint 2 right away, it should kind of give us an error. So let's try to mint 2. Again, I need to pass in my handy dandy Ethereum converter right here. I'm going to copy this remix into here, into the value, right? Boom. Hit the amount of 2, and if we hit transact, look at this. Sorry, we have minted out. Because at this point, you are trying to get more than what's necessary, right? That's right. So what we want to do is, in this case, we can only just mint 1 right now. So let's go ahead again. Let's go to 0.01 Ether. Copy this section. Go back to our remix section. Boom. For the value, paste that part in and hit transact. And let's see. Ooh, not enough money. Let's see. Let me go try that one more time. Boom. 1. Not enough money sent. What do you mean not enough money sent? Public price times 1. Let's make sure. Why is it not enough money sent? That's interesting. 0.01 Ether, right? Yeah. I mean, it looks good. Yeah, sounds good. Looks good. Let's try one more time here. Try again. Not enough money sent. Debug transaction. What do you mean by that? Measure the value should equal to the public price, which is 0.01 Ether, multiplied by the amount. Amount of 1. Again, transact. In GUI, right? It's in GUI. Oh, that's weird. So now it says, sorry, we have minted out. What? What is our current total supply of your... That's weird. Total supply, call. But now it says, sorry, we have minted out. Should be... Oh, because 0 plus 1... Right, it should actually be less than equal to max supply. I'm sorry, guys. This should actually be less than equal to max supply. So if max supply is 1, then we should be able to mint at least 1, basically. Yeah, that makes sense. That makes sense. So I have to go ahead and change this from less than to less than equal to sign. Okay, and let's go ahead and redeploy our contract one more time here. Okay, again, if I try to mint 2 here, let's try to mint 2 right here. It should give us an error with an ID of 0. Mint 2 with a 0.02 Ether, of course, which is the right amount of price. Let's pass it into here. Boom. Hit transact. And it should tell us, sorry, we minted out, not enough NFTs, right? You cannot buy anymore. Beautiful. But if I try to mint 1 with a 0.01 Ether price, of course, that should work. So let's try this one more time. Boom. Transact. There we go. You can see we minted 1 NFT, and that allowed us to actually do it, which is amazing. Okay, awesome. So now, moving forward from this, we've got the max supply. We've got the public price, right? Let's now make sure that we mint only a certain ID, because let's just say here, right? Let's just say if we go back to our Adidas originals. Okay. as you can see here, we only have how many NFTs? We have, right, 0 ID of 0, right? You see, if you look at this ID 0 portion, it's an ID of 0, and also an ID of, I believe it's an ID of 1 as well. So ID of 0, an ID of 1. So we need to make sure that ID is less than 2, okay? Let's go ahead and add that into the smart contract. So we say here, hey, require for the ID to be less than 2. And say, sorry, looks like you are trying to mint the wrong NFT. To mint the wrong NFT. There we go. Okay, awesome. So look at this. We've got the ID, we've got the message value, we've got the total supply. All right, and let's see what this actually looks like. Okay, and what I want to do now at this point is run this function. Look at my, deploy the smart contract, look at what we can see in OpenSea, and then go from there. Let's go ahead and deploy our smart contract here. Deploy, boom. Let's go ahead and mint our NFT, awesome, of 0. Amount is going to be 1, of course, right? And let's pass in that our correct number of, there we go, 0.01 Ether, pass that into here. So yeah, you have to hit backspace sometimes in order to pass that in and hit transact. There we go. We minted our NFT. And now let's check what is the URI we're going to get from here. And you'll actually notice here, if I get the URI of the ID of D of 0, kind of does nothing, as you can see here. Just kind of gives us the original URI, right? So we need to kind of fix that part because we need to be able to IPFS, we need to be able to get 0.json part. Without this, you know, if we just get this, it doesn't really know what NFT to showcase to OpenSea. Does that make sense, everybody? Doesn't really know that. So we need to tell it that. We need to set up the correct URI function to tell it that, okay? Again, let's go click on the contract. And to fix that part, let's go back to our OpenSea on ERC-1155. Right here, ERC-1155 Solidity. And let's look at the URI function. URI, say URI, of course, boom. We have a URI public view. So this is the URI function that actually, you know, just simply returns a normal URI for us, right? So what we're gonna do is we're gonna copy this section right here, this public URI, and put it into our smart contract. There we go, awesome. Right? We're going to override this URI function in general, right? Override returns to memory. So the first thing we're going to do is we're going to check, hey, is this URI, is the ID that we pass in, let's give it UN56 ID right here, is the ID that we pass in, is it, does it exist? We say require, right? Require that it exists, the what? The ID. Go make sure this is underscore ID. There we go. Exists underscore ID. Okay. There we go. Any updates on me getting married? No, guys. I'm not getting married anytime soon. Okay. That's hilarious. I love it. I love it. I love it. So yeah. So basically, we want to check if the ID exists at all in this smart contract and go from there, okay? Because if it doesn't exist, then we can just say, comma here, right? URI non-existent token, right? If it does exist, though, we need to combine the current IPFS URI with the ID and with the JSON. So I have this right here, this part for you guys that you can copy and paste it for you. So just make sure you look this up on your end. Here it is. Here's kind of how it looks like, right? So what we do here is we do return. We convert everything into a string and we combine, we use the API, the encoded packed. I know it's a little bit kind of wacky, but this is what combines different strings together, right? We're going to take our initial URI with the current ID, right? We're going to return that, combine that with the current ID of the NFT, so like 0 or 1, and then combine that with JSON. And yes, we do have an error here because we need to import strings as a as a import statement here. So let's go ahead and make sure we import our strings. And the way it kind of looks like is like this. Import open Zemplin contract utils strings. And that allows us to convert numbers into strings. Got it, guys? And there we go. So now we have this URI section, right? And we return the .json with it. And that's actually pretty cool because here's why, guys. Here's why. Let's go ahead and try to deploy it, right? Deploy it normally as we usually do. Boom. Let's mint our NFT as we usually do. Okay, amount of 1. Let's copy and paste that GUI part. Amazing. Right? Let's go back to remix here. I know this is a lot, guys, by the way. Transact. Okay, minted an NFT. Beautiful. This is a check mark. Let's scroll down. Let's go to our URI. Go to 0 for the URI. Hit call and check this out. You see this? 0.json. This part is exactly what we are looking for because this gives us the actual JSON for the NFT. And here's the JSON I'm talking about. So if I copy this whole IPFS and I put it into my link here, I'm going to remove this because this part is just like a shorthand for the actual IPFS link. I'm going to say IPFS. I have this IPFS stored somewhere here. There we go. Right? If I hit enter, it should certainly give me the 0.json for this IPFS. So let's see if it does. There we go. See? We've got our NFT for Web3 builders, right? External URL nazweb.com. Let's go. This is the link to the image itself, the name, the description, and then some attributes. So now the question becomes, do you guys want to see this on OpenSea and see how it looks like, just so we have an idea? I think so. Let's do it. Let's do it. Let's do it. Let's do it. So if you want to see this on OpenSea, we are going to, instead of hitting deploying smart contracts here, we're going to deploy using MetaMask. To do that, guys, you have to make sure you have MetaMask on here. There we go. All right. You have to make sure you are using Goerli Test Network, which is what this is, right? If you don't have the Goerli Test Network, guys, make sure you go to Show and Hide Test Networks and make sure this part is on, okay? And then go to Goerli Test Network, okay? And make sure you have Goerli Test ETH. You can see I have 0.4 test ETH. And then for you, it says portfolio, oh, site to keep tabs on your tokens. Oh, that's cool. That's cool. Awesome. I don't want this right now. So make sure you, to get the test ETH, just go to Goerli Faucet. Goerli Faucet. There we go. Right. And then you can actually put in your wallet address to actually sign to get free 0.1 Goerli ETH per day. Okay. So once you've got that, then let's go back to our remix. And let's go ahead and start doing environment of VM London. We want to select what? Injected provider MetaMask. And you can see it says Goerli 5 network, which is exactly whatever I have in my MetaMask. Right there. See? Awesome. Now let's go and try to deploy this smart contract and see what happens now at this point, okay? I'm going to hit deploy. It's going to ask me for a MetaMask. I'm going to hit confirm. Beautiful. Let's view this on Etherscan. So you can see on the bottom right here. What happens now? Let's see. Give it a second here. Give it a second here. Give it a second here. One more second. And yes, I am still very young, guys. I'm very, very young. I've got a long ways to go. But I do have a girlfriend, though, that I love. So there we go. So there's some intention there. Anyways, guys, so let's go ahead. We've got the contract deployed. Let's go look at our contract. Here it is. We've got the contract created, right? We can actually now mint our NFT. So let's try to use Remix to mint your NFT. So you should see your contract inside here, right? Let's mint your NFT. Select an ID of 0 and mint an amount of, let's just say 1. Of course, because we can only do 1 right now. Let's go and pass in that, whatever, how much this, 1 million or 10,000. I'm not sure how much GUI that is. But pass that part in. Boom. And then hit transact. Okay. And then hit confirm. You can see as it actually asks me for my MetaMask account, which is exactly what we want. Okay. Hit confirm. View on Etherscan. And hopefully it's going to confirm our NFT right here. And here's why I'm doing this, because I want to show you guys that it actually works on OpenSea. That's right. All right. How's your day so far? Hope you guys are doing amazing. It's a great day. It's a great day to be alive. Let's see. Let's refresh. Hopefully this properly. Yes, we minted an ID. You can see right here, ERC-1155 of token ID of 0 was minted. So now how do we see this on OpenSea? All you have to do is copy this contract URL, copy this part, go to OpenSea testnet, right here. Okay, view it on testnet. Beautiful. So you can see now we are in the testnet section. Awesome. Paste in the contract address, and here it is. Oh, not the contract. Hold on. Make sure we got this right. Hold on. 0x3, right? This is actually this one right here. 0x3. Make sure this one's right. Let's see here. Counts. What is this one? Is this the ERC-1155? I'm not sure. Is it? Let's see. Oh, I think this is the one, I think, right? No, this is the old one. Hold on. Let's make sure here. Paste in this contract address. This usually works. Maybe not this time. Interesting. So I guess another way to try this out is I'm gonna open up a current existing contract and just pass in the contract address of Goerli right here into this URL. Boom. Says page is not found. 0x3ACAB. I'm very curious why. I think maybe it needs time to, because we're on Goerli, right? Yeah. You minted our NFT. Yeah. So then what's the issue? I don't know. That's weird. Copy to clipboard one more time here. OpenSea. And sometimes these things can be so buggy. Come on. No? Created? No, nothing. Doesn't even see the contract. That's weird. Maybe we need to give it some time potential to see it. So let's go ahead and do this. Let's go ahead and move on. Let's give it some time for it to refresh potentially. And then we'll go from there, guys, okay? What's up, Nas? What's up? How you doing, lovely Leighton? Good to see you guys. Yeah, I'm curious why, guys. What are your thoughts, huh? I don't know. But anyways, I think we can go ahead and try this out here in a little bit later on. I think right now let's just keep moving forward, and then we'll go from there probably later on. But we have everything set up pretty well. I think everything works really well, honestly. Public price is correctly set up. Everything's pretty much the way it should be. So at this point, we've got the main functionality, right? We've got all of that. We're passing in the value. The question is now, as you can see, as we pass in money into the contract, we have this balance. Yeah, someone said, same thing happened to me if we deploy the ERC-1155. Maybe they're going through an issue right now, OpenSea in general. That could be it. No. That could be it as well. They might be just going through an issue because they have to technically pull this data from somewhere, right? And it's just like, where do you pull it from? I don't know. That's weird. That is very weird. So maybe they're just not working properly right now. That could be an issue of itself. But anyways, we've gotten all this data. We're passing in money. Now, as you know, whenever you pass in money into the contract, as you can see, the balance of that money gets stored where? Directly in here, in the balance. So we need to create a withdrawal function to be able to withdraw that money, right? So you can say, hey, transfer this money that we just got from the mint into my own smart contract, So we will go ahead and do that right now. So let's go back to Remix. We'll create a withdrawal function here. And that's actually a withdrawal function you can find anywhere on, smart contracts. For example, if you go to OpenSea here and you type in these guys, which are really cool, by the way. Let me see here, OpenSea here. And we type in Nifty Portal, Hollycode. What's up, Hollycode? If you type in Nifty Portal, right? If you type in Nifty Portal, if you look at some of the, for example, this is how I learned how to do smart contracts. If you go to details here, if you go to the contract address, if you go to the contract side, you actually find a withdraw function, withdraw, inside here. And it's the same withdrawal function that actually a lot of contracts use as well, right? All I have to do is just copy this contract. It is an MIT license, right? So, it is open source license because this is, everybody pretty much uses the same exact thing. And we're going to copy this directly into our smart contract as well, right here. Right? If you don't want to copy on your end, you can just do it on your end, guys. And here's what it consists of. I'm going to explain this really quickly here. Basically, withdrawal function allows us to withdraw from the smart contract. This is the address we want to withdraw to, right? What we do first is we get the balance. Get the balance of the smart contract. So let's just say 1,000 people minted, they give you 0.01 ETH. You've made some good money. Time to withdraw that money into your wallet so you can use it for, to continue building the project out for your team, stuff like that, right? Then what you do is you set this address to be payable, and all you do is just transfer the money like this. You transfer however much the balance is of the current smart contract into this address. But then you might be asking, hey Nas, can't anybody just do that? Is it true that they could just add in their own wallet address and just pass it in? Well, not necessarily, because only the owner of the smart contract can call this function, nobody else. I want you to understand that. Only the owner of that smart contract can actually call this function. Nobody else can call this smart contract, okay? So really, really important for you guys to understand that part. And then to show you an example here how this works, okay? Again, let's go ahead and try to deploy the smart contract again. Let's just go ahead and try that right now. So I'll hit deploy. I will hit deploy. Actually, before we deploy, guys, let's change the supply to be 20, just so I don't have to play around with this kind of stuff. Make sure to change the supply to be 20. Let's go and hit deploy. Hit confirm. Awesome. All right, looks like I think we're pending right now. Let's go ahead and run a Goerli Test Network. Hopefully that works really well. Well, wait, do you guys find these tutorials helpful? Because I feel like these are very, I really couldn't, the reason I'm doing this is because when I was learning smart contracts, I could not find this in one specific tutorial, right? There's a bunch of these tutorials that are all over the place, and you have to go looking for a bunch of different things to create a smart contract. But the smart contract that I'm teaching you is the same features we add to our clients, right? Whenever we work with an NFT project, right? We add all these features, of course, so we change things up. It's not like a copy and paste solution, it never is, but the general idea of it is the same, right? So I want to make sure you guys understand that part, right? So you can actually apply this to your own world and to your own clients, right? Great, contract has been created. Awesome, let's go back to our remix. Let's go ahead, go to our smart contracts and mint our NFT. So let's go and mint an ID of 0. An amount of how much? An amount of 1, let's just say. Again, let's pass in that GUI of whatever much it is. There we go, into the value section. Beautiful. And just hit transact. And hit confirm. There we go. Give it some time here. Someone asked a question, Nas, do you have a full tutorial of what you are doing right now? Like the one you have, Profit JavaScript. I'm React Dev, want to learn Web3 as well. So, great question. So, I don't have tutorial right now at this point, like the course. What I do have is I do workshops. So, I do workshops where in 3 days I teach you how to launch NFT projects from scratch. And I've done this, been doing it for the past 4 months, and we have so many amazing success stories. If you are interested in this, you will probably find a link down below to go ahead and apply. I only accept 12 people per month, so it's a very limited, unfortunately, right? And it is also not free. I want you to understand that. I'll be very upfront with you, right? Because I put in a lot of my time, a lot of my knowledge into this, and I do not want to kind of waste my time, you know, too much. So if you're willing to invest in yourself, right, and actually you want to be an NFT developer, you want to get to the same position as I am right now, you know, feel free to apply the workshop, the link down below. If you don't see it, I will probably add the link later on, okay? Awesome. So we went ahead, we deployed, we minted our NFT right here. Beautiful, awesome. So now, if you look at the contract, you'll find this, a balance, right? Meaning there's a balance of 0.01 ETH, right? But imagine you can have a balance of 1,000 ETH, 100 ETH. So the question becomes is how do we transfer this balance directly into where? Into us, right? Directly to who the creators of the project is. So we can actually use that money later on for other purposes, like paying the team and stuff like that. What you can do is, let's go back to our remix section. And what we can do at this point is hit withdraw, you see? Boom. I will use my MetaMask wallet right here. I'm going to say go ahead and copy to clipboard. MetaMask wallet withdraw function right here. And I'll pass in the address of which is my address, right? So I'm going to withdraw the money to my address. So you can see right now we have, why do I just keep getting all these stuff? 0.367, right? So if I hit withdraw and I hit transact, I want to hit confirm. And let's see if that actually works. Remember the 0.067, right? 367. Let's try to figure out if this will actually change. This should change to 0.37. Let's see. Look at that, 0.37. So that money has been transferred directly into me. And the reason why I could do it is because I'm the owner of that contract. That's right. You can see here, right there. And if I go back to the contract, you'll actually notice that now it has 0 ETH because that money has went from one account to another account. Does that make sense? Hopefully it does, guys, okay? Awesome. So we've got that portion. We've got the withdrawal function that looks really good. The next section I want to talk about is going to be the Allowlist functionality, right? Which is really, really important, is creating that whitelist, or nowadays we call it the Allowlist, right? So the people who are hardcore fans of the project can mint for a cheaper price. You know, they have certain, functionalities, probably some special requirements, all that stuff. So let's go ahead and do that. What I'm going to do right now is I'm going to create another function and call that a Allowlist mint, right? So I'm going to say function Allowlist mint right here. Same thing. I'm going to pass in the ID right here, and then it's going to be a public function, right? And that's pretty much it. It's going to be a public function that does all of this stuff, right? And of course, it has to be payable, as you guys know. Go ahead and make this a little bit smaller here and make the text a little bit bigger. Public, make sure it's payable, right? Meaning we can actually pass in money into this, right? Beautiful. For the Allowlist function, we're probably going to require a different amount. We're probably going to say, hey, maybe your price is cheaper versus the public price. So let's go ahead and do that. So here we'll say public price might be 0.02 Ether, while allowment price, I guess we call it, would be that. So let's go ahead and do UNT 256, public Allowlist price is equal to 0.01 Ether. All right, awesome, right? So this is a different price for the people who are part of the Allowlist, okay? And we can do, and so now what we can do is that we can require that inside here. So inside here, I'm going to say Allowlist mint is going to be require what? Require the message.value should equal to what? Should equal to Allowlist price, I guess. Yeah, Allowlist price. Right? Allowlist price times the amount. Right? Times the amount. And of course, we're going to mint this stuff inside here too. So we're going to mint this NFT inside here as well. right? And this is how we're going to require the payment, okay? Same thing. We also need to make sure we keep track of the supply, right? So that still gets copied over. And we need to make sure we're tracking for the ID as well. Make sure that's copied over as well, okay? Right? And now let's go and change this mint from a mint to make that into a public mint. Right? Because now we have two different mints. We have the public mint and then we have the Allowlist mint. So two different mints that we want to make sure we set forth, okay? Now, how do we know which mint is open? Because technically right now, I can mint either through this function or I can mint through this function. I can choose. If you look at whenever we deploy this, let's just say if we deploy the smart contract, let's just, again, let's not use the MetaMask because I want to test this really quickly here. If I do deploy really quickly here, technically I can mint both public mint and Allowlist mint and nothing is stopping me right now, okay? What I need to do is I need to set some variables to say, hey, currently the Allowlist mint is open or currently the public mint is open, right? So hopefully that kind of helps you guys out on that part. So let's go ahead and do that. I'm going to create two different variables and call them Allowlist open and then public mint open. Let's go ahead and do that right now. So say here, public boolean, because it's going to be boolean here, or bool public. I'm going to say here, public mint open, right, is going to be equal to false, right? And then I say here, bool public Allowlist mint open is going to be equal to, let's make that true for now, right? That's the first one, the mint is going to be open, okay? So basically, if this is open, means we're good. If this is open, means we can use the Allowlist mint. And so we can use these variables now to figure out, hey, which function are you actually allowed to use? So in the Allowlist mint, we're going to say, hey, require that the Allowlist mint open is true. Whitelist of without strong. Right here. Boom. Mint open should be true. Otherwise, basically we say here, if it's not true, that means what? Hey, we're not open yet. I mean, the Allowlist is closed, right? That's what that means, guys. So that's what we say here. We say here, Allowlist mint is closed. This means only when this is open, then you can mint, right? Let's go back to the public mint now. We say here require public no, I said this wrong. Public mint, I think it's called open. I believe so, right? Otherwise, we say public mint closed. Mint closed, right? And that's pretty much it, right? So this is how these projects, whenever they mint NFTs, they have the Allowlist mint, they have the public mint. This is exactly kind of what they do to make sure they keep track of this kind of stuff, right? Now, you're like, Nas, okay, so that means we set these variables. Okay, but what if we want to change these variables? Good question. Good question. What we need to do is we need to be able to create an edit function, right? Create an edit function here. Let's go write this down. Create an edit function that will edit the variables, the mint windows, right? And so what we can do at this point is just create an edit edit mint windows here. So let's go and do this right now. So we say here function edit mint windows. Boom, boom. Inside that, we are going to pass in two things, right? Two things we're going to pass in. The first thing we're going to pass in is going to be a boolean that's going to be a underscore public mint open. Why? So we're going to say, hey, this point in time, now the public mint is open, or at this point in time, now the Allowlist mint is open. And then we say bool underscore Allowlist mint open. Beautiful. Okay. We have this error right here. It says no visibility specified. Okay. So we need to specify this is going to be an external function. An external function right here, right? And External means, by the way, but those of you who don't know, external means that only the external functions can call it. You cannot call this function internally within the actual contract. That's what that means. And people do that because it does save on gas fees. So if you don't need to call this function within the actual contract, just say external basically, right? And one thing I want to make sure is who can call this function? Oh yeah, anybody call this function. No, only the owner can call this function. We say here only owner can call this function, because otherwise people could just change their own windows and that just makes no sense, right? Which is no bueno, which is no good at all. So we say here only owner, and at this point we say here now whatever the owner passes in, that's gonna be what's set. So we say now public mint open is equal to what? Underscore public mint open. Boom. All right. Now we say allow list mint open is equal to underscore allow list mint open. So we're taking these variables, we pass it into the function, into the contract, and passing them directly and setting them in the actual contract itself. All right, beautiful. There we go. And so now only certain people at certain times will be able to mint their NFT, and that is perfect, right? That's exactly what we are looking for. Okay. Now, moving forward here, guys, we're not done yet. We still have a good amount to go. This is, by the way, a very long smart contract. But that's perfect because this smart contract has everything you pretty much need in general to launch an NFT in general, right? So let's go ahead and go to our edit mint windows into deployment section, and let's test this smart contract out with the editing of the mint windows, right? I'm gonna go ahead and hit deploy, remove my previous one, and here's my new one that we just deployed. Beautiful, awesome. Okay, let's go and do this. So as you can see right now, only the allow list mint is open. So if I try to do public mint, let's go and let's go ahead and try to pass in some money like this right here. For public mint, we need to pass in 0.02 now. So right here, amount of one NFT, pass in that gray amount, and hit transact. And it says public mint closed, right? Which is perfect. But if I do allow list mint, so ID of 0, I get amount of 1, right? And I have to pass in this time 0.01 ether instead of 2. So copy that portion, go back to our remix. Let's go ahead here, paste this in. Awesome. And now hit transact. Boom. See, that part went through. And it minted our own NFT, which is exactly what we are looking for. Okay? Exactly what we are looking for. Now, right now, what happens now, the issue becomes that, well, now at this point, still anybody can technically mint this NFT, right? At allow list mint. If this is open, there's no requirement on the address of who can mint and who cannot, right? Anybody, if you guys are watching on YouTube, you can call this function and just mint your NFT, and then you're like, hey, why should I use this function? This function requires more price because the public price is 0.02 ETH. Why not just do this allow list mint function and get it for 0.01 ETH? Well, this is where we actually need to store the people who are part of the allow list, and that part is really, really important, you guys, okay? So let's go ahead and add that part in. How are we going to store these allow list mint? And someone had a question. It's a really good question. They said here, how do you create a whitelist of 100 addresses without storing them in a smart contract? The thing is, you can't really. You have to store them in a smart contract, guys. You actually have to. Unfortunately, it's not as easy. Yes, you can store it somehow in the API. That's fine. That's possible. But the problem becomes is that now you have to call the API, use something like Chainlink to call the API, and that becomes very, very costly on the gas fees. And nobody wants that. Okay? So what we want instead is we need to do something where we just store it in the actual contract. So hopefully that answered your question, okay? So hopefully that answers your question, guys, okay? So let's go ahead and look at this part right here. let me go ahead and check this out. So I'm gonna number one figure out a way to store the allow list. Okay. Nabi just said there's an issue with the link. Okay, I'll take a look at the link later. Don't worry about it, guys. So let's go take a look at the allow list here. And how are we gonna store this data? Well, we're gonna store this data in something called a mapping, which is really, really cool because a mapping actually stores key value pairs, right? So we're gonna store a key value pairs from an address, right? So let's just say we have an address right here of like 0x blah 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 store to, and this is true. True means it's part of the allow list. Okay, so it's gonna create that mapping here. Mapping. I'm gonna say here it's gonna be from an address down to what? Down to a boolean of what? Of the allow list. There we go, right? So this is where your addresses will be stored in terms of who's going to be able to mint using the allow list. All right, beautiful, awesome. But of course, now we need to set that allow list. So we need to create a function to set the allow list. So let's go ahead and do this. Create a function to set the allow list. And what we're going to do is we're going to pass in a list of addresses, almost like an array of addresses, into this function and then create it that way, okay? So how do we do that? Well, there's a function called, like I said, set. So let's go ahead and do that. Let me go ahead and make sure I have it properly done. So like I said, let's go ahead and do function here. Set allow list. Allow list, all right? And we're going to pass in an array of addresses. So we'll say address, an array, call data addresses. Okay, it's an external function. External function, and only the owner should be able to call this function, right? Because otherwise, that's pretty bad, right? Otherwise, it's like everybody can add themselves to the allow list, which is not good. We're gonna loop through every single address. Just gonna do for loop. I'm gonna say uint 256i is gonna equal to initially from 0. We're gonna loop through every single one and add it to the mapping here. I should be less than addresses dot length. There we go. And we'll say I++. Like a normal loop. You guys should probably remember this. We're gonna say the whitelist now, or the allow list, which is that mapping, at the address, which is the addresses I, see this addresses? Addresses of I, there we go, should equal to true. So this is how we are going to add these addresses to the actual mapping itself. It's going to loop through the addresses, right? And add the address, individual address, with a value, a key of the address and a value of true. And the reason why we do that is because after we've added this, we can actually check it now. So in the allow list mint, we can say here, require that the message.sender is actually in the allow. We say allow list, and the message.sender is actually in it, right? Otherwise, if he's not in it, then we say you are not on the allow list. Simple as that. You are not on the allow list, right? And this is how we check if you are on the allow list or not. Make sense? So let's go and deploy this and actually see how this works out. Let's go and see how this works out. Oh wait, does that still, OpenSea still work by any chance? I'm just curious. The other smart contract, for some reason, it did not work the last time. Let me try this one now. OpenSea testnet. Let's try out the previous smart contract to see if that works or not. There we go. Nope, still does not work. I'm not really sure why. Usually it does work. Usually it has no problems whatsoever. For some reason, it does. For now, it just does not want to be part of this, which is just no good. Like I even have it inside here. Oh, no, there it is. Actually, it is there. It's just, it was hard to find. Okay, here it is. We do actually have it. So, okay, that's good. So we do actually have it. See, created in October 2022. Awesome. So we do actually have, you see, it just took some time for it to actually update. That's great. Anyways, and you can see I'm using Doodles here. By the way, I am using Doodles as an NFT just for educational purposes. Don't worry, I'm not stealing this. This is not what this is for. Okay, guys, want to make sure you guys understand that part. There we go. Awesome. All right. So at this point, we got the allow list. Let's go ahead and test this allow list fully. Again, let's go back to our remix. Let's go ahead and deploy our smart contract. Awesome. And here's what we have so far. And as we know, right now, we are not able to do a public mint because public mint is currently what? False. So the allow list mint is true. Now, so let's go ahead and try to mint one NFT. Again, we're going to mint one NFT. We are going to pass in that 0.01 Ether. And it should give us an error. That's the goal here. It should give us an error. So let's go ahead and do that right now. Let's paste in our value, which is how much money we're passing in, and hit transact. And yes, it does give us an error because it says you are not on the allow list, which is correctamundo, right? Because we are not on the allow list. But we can put ourselves on it. So check this out. So we now say, we go to here, and we go to set allow list. You see this function set allow list. And we're going to pass in our current address, my current MetaMask address, which is what this one is, right? This one right here. I'm going to pass it in as an array into a string like this and hit transact. And there we go. So now it's saved, basically, if we're on the allow list or not. Okay? Right? And if you hit this allow list portion, you'll see it actually says true because we are on the allow list right now. Okay, so let's go ahead and try to do mint, allow list mint one more time. And this time it should be what? It should let us through. That's the goal here. Okay, let's pass in our Ether value. Somebody said, what about max mint per wall? Oh, great question. That's a great question. We can do that too as well. Man, you guys just coming up with great questions. I love it. All right, so let's go ahead and push that in. So again, let's go and add that value in, 1,000. Okay. Allow list right here. So let's go ahead and do a transact. Says you are not on the allow list. Oh, they are not the allow because I added in the wrong address. Technically, guys, so we're actually minting with this address. This is this makeshift one. So we need to copy this one. This is my fault, and add that one to the actual allow list. Boom. So copy that one, hit transact. There we go. Okay. There we go. And now technically we should be able to. Let me try this one more time. Let's pass in our GUI into here. Boom. Hit deploy. Hit transact. There we go. It all went through. You can see now because I added myself to the allow list, I'm all good. I can actually mint this NFT. Does that make sense, everybody? Hopefully it does. Okay. Right. I just had to make sure I actually pass in the contract address or the wallet address of this one because we're not using MetaMask right now. We are using a private blockchain through Remix. Okay. Make sense? Beautiful. Awesome. Yeah. So that is what's going to allow us to mint through the allow list right now. Okay. And moving forward, I want to show you kind of like what would happen if I, edit the mint window. So if I go to the edit mint window section, I can say, hey, public mint now is going to be true. And allow us mint open is going to be false. I hit transact. As you can see now, that's good, right? And if I try to do allow list mint again, it actually won't work because you'll notice that it's actually not open. So if I go to try and mint this one more time here, boom, hit deploy. That's not what I wanted, sorry. If I pass this part in again, oops, and I hit transact on the allow list mint, it should tell me an error, allow list mint is closed, right? So there we go. Question, would this allow list cost a lot, guys, or it's optimized? So A lot of people still use it this way to actually add the allow list, but nowadays to also make it a little bit cleaner, some people also use something called Merkle root, guys. So Merkle root, and this is a whole separate video I have to do on Merkle roots, which is you're basically taking a list of addresses and putting them into like a tree structure, which takes up less space than an actual mint, right? And an actual like an array of addresses, right? So what our goal will be is I'll create another video, but this is gonna be on Merkle roots, and that's gonna be more guest optimized than what this part is. But this is the usual way, you know, people would save their whitelist mints, allow list mints, kind of like in that sense. Okay. Awesome. Question: what will be max per wallet? I like that one. I can actually add that one as well. So max per wallet. But before I add that in, I do want to clean up some of my code here, guys, because right now it's a little bit messy. And why? It's because you notice a few things, right? What do you notice here? You notice here that we have this right here, complete copy. This right here, where was it? This complete copy, right? And this complete copy. So I want to extract these out into its own function so we don't have duplicate functionality going on here. What I'm going to do is I'm going to create another function called mint. That's going to be passed in it's going to pass in the ID also, right? UN256 ID and the amount right here. Beautiful. Awesome. And it's going to be not a payable, it's going to be an internal function, right? So only we can use this function internally. Inside here, I'm going to copy whatever we do that is a duplicate. So for example, this we do in both public mint and whitelist mint, right? Awesome. This we do in both public mint and allow list mint. Awesome. And then one last thing that we do in both is what? The ID check, right? This one right here. Boom. Same thing goes here. Boom, right? So I can now remove this part. Remove this part from the allow list mint as well. Again, this just keeps it so much simpler, right, guys? So much simpler, right? And only use functionality that is necessary for that function. And I'm going to use the mint function instead. Right here, see? Same thing goes here. I'm going to use the mint function instead. Right? So we have whatever specific to that function we have that's inside here, right? And then the rest is basically, it's a duplicate, so we'll just put it into its own internal function. Hopefully that kind of clears some things up for you guys, okay? Beautiful. We've got that, we've got that, we've got that. I like it, I like it, I like it. The next thing I want to do is let's go ahead and make sure that we have a max per wallet. So let's go ahead and do a max per wallet. So let's do uint public max per wallet. Let's maybe do what? How many should we do max per wallet? I don't know, 3. Let's just say here, uint. There we go. Awesome. To make this max per wallet work properly, like I said, we save that, and then all we have to do is just simply check it later on. We have to save it in like almost like a transaction, you know, in terms of how many you're actually allowed to mint for every single one. So let me go make sure I'm actually all correct on this one. There we go. Awesome. Yep, that's exactly what I'm looking for here. So what we can do, we need to actually save however, basically what is the balance that people have. So whenever we mint an NFT, right? First thing we do, we need to save that data. Right? Is whenever we mint here, let's go and save that data and start with somewhere inside here. It's like, hey, you know, this person has minted this many NFTs, right? And to do that, we are going to do a purchase. So purchase, let's call it wallet. Purchase wallet. Let me see. Purchase per wallet. Purchases per wallet. Right? We're gonna save into a message.center into whoever is calling the function. I'm gonna add in the amount, so plus equal to amount, right? And again, this is going to be a mapping as well, right? So I'm going to save this in a mapping too, as well inside here. So we'll say mapping, going to go from address to what? To a uint 256, right? And say, and it's going to be purchases, again, purchases per wallet, right? Let's make sure I get that right. Purchases per wallet. Purchases per wallet right here. Per wallet, right? So we have this data, and every time somebody mints, we make sure that, right, we add that into the purchase per wallet, right? So we keep track of, hey, if you minted 10, we will know it's 10. If you minted already 15, we know it's 15, right? And the max we're allowing right now is only 3. Only 3 right now, okay? All right, and so what we're gonna do right now at this point is in the mint function, I'm gonna require that. I'm gonna say require that the purchase per wallet of the message sender should be less than or equal to, right? Purchase per message sender should be less, of course, plus whatever the amount we're trying to buy. So if we're trying to buy 5, right, should be less than or equal to the max per wallet, right? Otherwise, you know, we could say, hey, wallet limit reached. There we go, right? And so this makes sure that, hey, we can only buy, so we can buy 2 or 3 NFTs per wallet. Does that make sense? Hopefully that kind of makes sense to you guys. And that's how we added the limit inside right here. Okay, public mint. And it's, again, it's on an internal mint because why? Because this is something that's duplicated around public mint and the Allowlist mint. Does that make sense, everybody? Hopefully it does to you. Okay. And we can actually now test this as well. So let's go ahead and test this out. If I'm going to try to, let's just say, mint a few NFTs using the public mint, you'll see that it will actually give me a wallet limit, right? Let's go ahead and try that right now. And let's go ahead and remove this portion. Let's go ahead and hit deploy. Awesome. And let's try to mint right away 4 NFTs. Let's make sure we have, let's change this to up to be where the public mint is going to be true, while the Allowlist mint is going to be false, because we want to use the public mint function right now. Okay, awesome. Beautiful. With the public mint, if we want to mint 4, we say ID of 0, amount of what? How many? 4. And what is the ether? 0.0 what? 4. I believe it's actually 0.02 times 4, so it's actually 0.08 ether. Because as you can see, we are requesting how much? 0.02 ether per public price. We need to pass that part in. Boom, 8 right here. Awesome. Let's go ahead, transact. And it should say wallet limit reached, because you're trying to buy more than what you're allowed per wallet. But if I try 3, right, and if I pass in 0.06 ether, that's going to work. Right here. Let's go and pass that in, 0.06 ether, hit transact. Boom, we've got now our, 3 NFTs per wallet, right? And at this point, guys, that's pretty much it, guys. So we have gone through everything we need to go through in terms of, I would say this smart contract is very complex at this point, has so many different functionalities, right? You can actually take this to your clients now and actually apply this, right? This is kind of what we do, but we do it on a bigger scale a little bit with our company. And for those of you, by the way, those of you who are interested in launching your own NFT project, maybe your company or brand, that's what we do pretty much. We'd love to help you guys out. If you are interested, we have a link down below to go ahead and schedule a call with us so we can figure out how we can help you, okay? All right, I'm not done yet though, because the next thing I want to do is a payment splitter. What if I want to be able to split up payments, right, across my whole team, right? Let's say that you launched an NFT project, you guys made $1 million, okay? Again, hypothetically, and 10% goes to developers, 10% goes to designers, another 10% goes somewhere else. How do you do in a way that's trusted that money can be split up evenly across, the team? And that's where something called payment splitter actually comes in. So check this out here. So this is so cool, by the way. You have to listen to this, okay, guys? So we have a payment splitter function on GitHub. Open Zeppelin here. And this actually splits up the payments of the NFT. So you can actually release. So if it's 10%, it will release 10% of the mint, right? And you can release these funds depending on how many shares. It's like you have shares of the company, and depending on how many shares of the company you have, you get that money back, okay? Right? So let's go ahead and try that right now. Let's go ahead and do a payment splitter right here. To add a payment splitter, we need to, of course, import it. And how do we import it? We import it directly from the contracts finance section, right? So I'm going to do that right now. Let me go ahead and do that right now here. So I'm just going to copy this whole section here, remix, and here it is, right? So import from OpenZeppelin right here, OpenZeppelin contracts finance, and then payment splitter.sol. Hopefully you guys can copy and see that, okay? Beautiful. Now, at this point, we need to include this as part of the contracts. We say is ERC-1155, and then we say payment splitter right here, right? And you need to define the payment splitter actually on the constructor, and that's really cool as well. So to do that, you'll see here, I'll show you here in a second here. So we say ERC-1155 supply, but also we say here, payment splitter, and this is really cool. This is where you define how many shares actually is passed in, and then what are the payees. Yeah, so pretty crazy here. So I'm gonna say here in the constructor, I'm gonna pass in who's getting paid and how many shares each person has. So let's just say here an example here. This is my account. So I'm gonna say here address. This is an array of addresses, memory, just temporary memory of payees. Underscore payees, right? This is who is the owner of this NFT project, right? Yo, what's up, Frank? Good to see you, my friend. Right? It's who is the owner of this NFT project, okay? So that's the payees. It's who's going to be going to be paid out. Now, the next thing we need to do is how many shares does each person have? So I'm going to say here UN256, an array of this, memory, and underscore shares. So let's just say I have 10 shares, and then someone else has 90 shares. That's 100 shares, means I get 10%, someone else gets 90%. Hopefully that makes sense to you guys, okay? So, and that gets passed into the constructor through the actual deployment script, okay? And then we pass that in directly into the payment splitter, payees, comma shares, underscore shares. And this is how you split up payments off the smart contract, which is so cool. Now, usually at this point, you would remove the withdrawal function. I'm going to keep it there for now, but usually at this point, you would remove the withdrawal function because the payment splitter is what allows you to withdraw the money. That's right. So let's go ahead and test this out because I do want you to see this, and it's really cool. And you would be excited to actually see how this works properly, okay? Let's test this out. I'm going to hit compile, of course, make sure you compile your NFT, right? Compile my NFT. Let's go ahead and hit deploy now at this point. And we're going to deploy using our MetaMask wallet. So let's go ahead and remove all this other stuff. We don't need this. Let's deploy using our MetaMask wallet right here, okay? Now, it says, you see, when you deploy now, you have to specify who's the constructor arguments. In our case, it's going to be two payees. So we have two payees. One is going to be me. Let's just say I get 10%. So here's my MetaMask wallet address. This is my 10% right here. Boom, right? And then the other person is going to have the 90%, which could be potentially, the founder or someone else. So let's go ahead and create another account here. Maybe account 2 here. Why not? And this is 0848, okay? Boom. Again, put that into the quotes in the array, right? You can see here, these are the two addresses that we have saved right now so far. 848 and 57. In the same way, you have to specify how many shares these people have. So the first array ID, right, of token ID 0, it's going to be, I have 10 shares, versus that other person with the address of 848 will have 90 shares. We don't need this to be in the quotes actually. So comma 90 right here. Okay. And let's try to make this work. And let's go ahead. Let's go back to our original account 1. Awesome. Let's go and hit transact. All right. So we're going to deploy this contract. Awesome. I like it. All right. Let's see what works here. Boom. Let's see how this works because this is pretty much the end, guys. I'm excited for this. I'm really, really excited for this, guys. I want you to see how this exactly works, okay? And weirdly enough, where I learned from this, I learned this from the Adidas Originals. So this is how I learned smart contracts, actually. You'll actually find as well. So if you go to details section here, in their contract address, in the Adidas Originals one, you actually notice that they have a payment splitter on their side too. Right here, see? That's where I learned it from. Public information, guys. Public information you can just use from anywhere. Okay. Let's see. It looks like it's still pending here. Beautiful. Contract has been created. I love it. Let's try and mint our NFT, guys. You ready? Here's our contract. Okay. Let's mint our NFT. So right now, I believe only the Allowlist mint is open. So we need to change it to be where only the public mint is open. So true, while Allowlist mint is going to be false for now. Hit transact. Hit confirm. Let's go, Mr. Frank. I love it. So hopefully that's went through. Let's make sure it did go through. True. Let's see. No, it's still pending, looks like. Once it's done pending, we can go ahead and test out the public mint. Let's go ahead and get this ready. So let's try to mint 3 NFTs because we're allowed 3 NFTs per wallet, right? So right now, I'm going to mint 3 NFTs. So ID of 0. How many? 3 per wallet, of course. And again, if I try to mint more, it actually will give me an error. Well, I'll try to mint 3. We need to pass in how many? 0.06 Ether. Right here. Awesome. Let's pass it into the value section in GUI. This is how much we have in GUI, of course. And at this point, this public mint, let's go ahead and try to transact. Let's see. Look beautiful. 0.06 Goerli ETH being sent. Hit confirm. Let's try this now. Let's all make sure it all works. Let's go ahead and mint these NFTs. Man, this guys is the ultimate smart. I mean, I call it an ultimate smart contract for a reason because it really is the ultimate smart contract. There are so many things in this smart contract, guys. You know, it's insane. How do I mint from a contract if I have whitelist? I'm not sure what you mean by that. How do you mint with a whitelist? I specified that in the smart contract, guys. Okay. So there we go. 3 have been minted. Okay, beautiful. For this specific smart contract. And you'll notice that we have a balance now of 0.06 ETH, okay? 0.06 ETH balance. Beautiful. Let's go back to our smart contract and you'll see it right here. Now, let's try and now release the fund. So let's say we made, 0.06 ETH of, money, right? 10% of that 0.06 should go to me, and then the other should go to the other person. Let's try it now. Okay, so to do a release of funds, here's what I can do, guys. You see what says release, which is how many have been released so far. To release our funds, we just say there is a release function here. Release right here. Right? Release. Actually, there should be 2 release functions. Let me see here. Actually, no, here, this one right here. This one on the top, release. So release, basically, we're gonna release to what account? The account that we have, the one we specified was to this one, the 357, right? That was the first one. So I'm gonna try to release it to this one and hit transact. And hit confirm. Let's see what happens. Yeah, if you wanna do a burn, then you need to create a separate smart contract to burn this NFT and to get another one. Yeah, you have to create another separate smart contract. That is very much correct. Yep, correct on that one. All right, I think it's done. Okay, so you'll notice here Now it says 0.054 ETH because 10% of 0.6 was exactly, I think, 0.0 something, right? Right? So 0.054 went to me. It went directly into the 357. You see, we've increased our amount here. Now, the 848, which is the other person, right? They had 90% of shares. Let's go back to that one now. Account 2. Beautiful. 848. See, notice the 0.2 right now. This should increase. So now if we try to release for the other person, copy to clipboard. Let's release for the other person here. Command V. Hit transact on this one. Okay. Hit confirm. Let's see. Hopefully this will be done here in a little bit here. Give it some time. This is really cool. I love this kind of stuff. All right. Hopefully that went through. Looks like it's still going. God, this is a 2-hour smart contract for just ERC-1155. How insane is that? I'll call that pretty insane. Awesome. There we go. Sweet. So release the funds, as you can see, right? Let's go back to our here. Now we have a balance of 0, and let's look at our 848 one. 0.254. The rest went. So 90% went to this address, 10% went to the other address. You can see, and that's how we split up funds post mint. And that's pretty much it, guys. So what we can do actually now at this point is let's go and double check this contract on OpenSea. Hopefully it works again on OpenSea. Let's double check this. Let's go to OpenSea testnet. Paste in our contract address. Not there. Again, I think it just takes some time for some reason. But I think if I go to a current contract, not sure. Let's just say this one. This one is not Goerli, and I just modify this to be the address that we have here with a 0 NFT. There you go. It showed up, right? So for some reason the search does not work very well, but here is our NFT, right? All I did was I went to a current contract with Goerli, and I subbed and I removed the contract address with our contract address and put the ID of 0. And you notice, guys, here it says 3 owned by you. So I have 3 of these NFTs. That's what makes this an ERC-1155. Does that make sense, right? If we have 3 of these, if I go back to the contract, there's an ID of 0, but there's 3 of that ID. Hopefully that makes sense, guys. And that's it pretty much, guys. Hopefully you guys enjoyed this video. Hopefully you guys enjoyed this. As you always know, go ahead and hit like, subscribe for more videos like this, guys. I'm going to continue doing more smart contract tutorials. I want to do a staking tutorial moving on forward. If you yourself want to be part of an amazing Web3 Builders community, we probably have a link down below to join a Web3 Builders community where we teach, NFTs, workshops, stuff like that. If you don't have the link yet, it will happen later on because we're still in the development phase of this. If you're someone who wants to build a NFT project and you need the tech help, you're someone who like, hey guys, I need the tech on this fully. That's what we do exactly as well. There should be a link down below to schedule a call with us and to get started, to do a free consultation on an NFT project. Okay, I think that's pretty much it, guys. In that case, I hope you guys have an amazing day, and I'll see you guys in the next video. Thank you, everybody. Bye.